We have here a mass current technique method applied to a practice problem. Let's go ahead and say this mass current dot one. Okay, the circuit has quite a few elements. Let's start with a voltage source minus voltage supply Ps. Then we have an inductor here and resistor at the bottom here. The interesting piece is this diamond, which is 2 times P sub R, where we will see P sub R as a voltage across resistance, which we will see shortly. For now, let's complete the other parts of the circuit. So we have another current source here. IS is the name we're going to give. This is another resistor, 4 ohm, and the inductor is 3 Henry. Okay, so these are the solder pieces. And let's say we have a lower mesh here. With a resistance and a capacitance. Tube headed. The resistance has the voltage P sub R across it. There you go. And this P sub R is showing up in the diamond. So that will show all these elements. Let's go ahead drawing the mesh current. I sub 1 is here. This is mesh number 1. I sub 2 is here. Mesh number 2. I sub 3 is here. Mesh number 3. There I2, I1. And this resistance is 5 ohm. And this is I sub 4. So we have PS, I1, I2, I3, I4, 2 ohm, 3 Henry, 2 VR, 4 ohm, 5 ohm, and 2 farad. And we have to come up with the matrix representing the KVL equations for this problem. Now, we could redraw this circuit to make it look a little bit better in this way. We have 3 Henry here, and we have the diamond here. The supply, of course, is here, voltage supply plus minus PS. Now, the nodes up here, these 2 nodes, actually all of this is one single node. So it is okay to make this smaller and just make it here, so that will avoid any kind of unnecessary distraction as we go ahead applying the MC method to solve the problem. So this is what we see happening in this circuit. So one of the big deal about circuit analysis is to consider simplification as much as we can. That will be a good way to go with. Now let's remember these are the mesh currents, and we have the transistor having the output 2 times PR, where PR is the voltage across this resistor, which is 5 ohm. 2 farad is here, I sub 2 is here, I sub 1 is here, I sub 3 is here. So that way we're looking at a little more organized perform the same given circuit. So supply then 3 Henry, 2 VR, 5 ohm, 2 farad, 4 ohm, and IS. Now we need to understand that we could use the operator notation. So using the fact that the voltage across the inductor is given by L di going through the inductance over dt could be expressed as P sub L is L capital DIL, where capital D is the operator d dt. So we can write d capital D is d dt. This is the operator notation, and this is pretty handy in this kind of situation. Along the same line, when we have a capacitor, the current through the capacitor is given by C d voltage across the capacitor dt. We could transform this in the same way as IC equals C capital D VC. Or conversely, we can express VC as 1 over C D inverse IC. So this is another way to get the voltage across the capacitor. So we would be using this kind of representation quite a bit. So if we go ahead, write the voltage across the resistor V sub R as, from Ohm's law, the resistance is 5 and the current is I fourth. So 5 I fourth. And notice that looking at the two meshes, mesh number 1 and mesh number 2, we see there's a conflict between 1 and 2, and it looks like 2VR, which is the diamond current source, is in favor of the direction of I2. In other words, I2 minus I1 is equal to 2VR. But VR being 5I4, we can write I2 minus I1 equals 10I4. So we could express this as minus 1 times I1 plus 1 times I2 plus 0 times I3 plus minus 10 times I4 equals 0. So we will use this expression later in the matrix equation. So let's save this thing in a box. Next, considering the super mesh of 1 and 2, so we will go down that bigger loop. What we encounter is KVL around the super mesh 1 and 2, 1 and 2, we get minus Vs plus the voltage across the inductor. So again, remembering the voltage across the inductor given by L operator capital D times I sub L. So that will give you L is 3 capital D, and this time the current through this element is I sub 1, so I sub 1, then plus 4, we are in the right edge of mesh number 2, where the resistance is 4, and then there's a competition between I2 and I3. Using a house rule, I2 prevails over I3, so the balance is I2 minus I3. And the next term is The resistance 2 ohm is there, so we're looking at the voltage across the 2 ohm, and there is again competition between I1 and I4. I1 prevails using the house rule, so I1 minus I4 equals 0. So this is to say minus PS plus 3dI1 plus 4I2 by expansion, of course, minus 4I3 plus 2I1 minus 2I4 equals 0. We could express this as 2 plus 3D times I sub 1. Notice the operator D is operating on I1 plus 4, 4 I2, then plus minus 4 I3 plus minus 2 I4 equals PS. Next, we notice that in mesh number 3, I3 is equal to IS, which we could express as nothing times I1 plus nothing times I2 plus 1 times I3 plus nothing times I4 equals IS. So that will be another expression. So we have the 3 boxes so far. Since we have 4 unknowns, we have to have another expression to complete this. So let's see. If we look at mesh number 4, we have KVL around mesh 4. Which is the voltage across the 5 ohm is 5 times I4 plus the voltage across the 2 ohm has a competition using house rule. I4 will prevail over I sub 1, so it's a 2 times I4 minus I sub 1. And then as we continue, we see the voltage across the capacitor. Notice that the voltage across the capacitor is given by V sub C is 1 over C D inverse, which is D minus 1 I sub C. So in that manner, we will get 1 over C is 1 over 2, and D minus 1 I4 equals 0, which is to say 5 I4 plus 2 I4 minus 2 I1 plus 0.5 D inverse I4 is 0. What shall I say? By reorganizing, we have another box here, folks, which is minus 2 I sub 1 plus 0 I sub 2 plus 0 I sub 3 plus 5 and 2, 7 plus 0.5 D inverse I4 equals 0. So this is the 4th box. So our matrix expression will be in this form. Let's see this. Let's close this thing. We have I1 and I2 I3, I4, and on the short side we have 0, PS, IS, 0. The one on top is 0, of course. So the elements -1, 1, 0, -10. This is from the first box, and then we have the second box gives us 2 plus 3d, 4 minus 4 minus 2. The third gives us 0, 0, 1, 0. The fourth gives us -2, 0, 0, 7 plus 0.5 d minus 1. So that would be the matrix expression. I have alluded to the fact of the house rule, which is a convenient method to know which current prevails. If we are in a certain mesh, the current in that mesh prevails over every other current uh, as they compete over the branches. So that will be it, folks. Hope this has been a fun problem. Have a good time working on it, but practice as much as you can. Thanks for watching.